In this video, we'll walk you through the derivation of the formula to calculate the future value, which is defined as follows. We're saying the future value equals to the regular payments of x into 1 plus I to the power of n minus 1, all divided by I. Now, this formula helps you to calculate the amount you will have in the future if you make a regular payment, say, of x over time. Now, imagine you are making regular payments of X at the end of each year for n years, and the account earns an annual effective rate of I. Now, to find out how much money you will have at the end of n years, we need to calculate the future value of this series of payments of X. Now, to demonstrate this, I will use the following timeline. So now we are saying we are making a series of payments from time 0 to time n. So now it will be first period, second period, and so on until the nth period. So now we are saying we are making a series of payments of x. So now in the first at the end of the first period, we'll have to make a payment of x, and at the end of the second period, we'll have to make a payment of the regular payment of x, and so on until the nth period. So now what you want to calculate here is we want to calculate the future value of these regular payments made at the end of each period. So what we want to do is we want to accumulate these regular payments of x to what? To time n. So we want to accumulate these regular payments to what? To time n. But then, okay, in order to do so, what you have to do is we are going to say the future value of these regular payments of x will be equals to, we'll start by the first payment, which is made at the end of the first period. We are going to say x. In order to accumulate it, we are going to say 1 plus I to the power of n minus 1. We do not account for the first year because the payment is made at the end of the first period. So that's why we are saying n minus 1. Same applies to second payment. We are going to say plus x into 1 plus I to the power of. Now, for this one, we are not accounting for 2 years. So for 2 periods, then it means it will be n minus 2. And we'll carry on until the last payment. So the last payment, it is made at the end of the nth period. So this one we do not accumulate it. So now it will basically be 1 plus I to the power of 0, which is 1. So now, as you can see, we have the common factor of what? Of x. So now we are going to factor out x. Okay. So now it will be 1 plus I to the power of n minus 1 plus 1 plus I to the power of n minus 2, then carry on until the last one, which is 1, basically 1. Okay. So now, as you can see, now we have a geometric series, but then in order to calculate this one, we have to factor out our common factor on this geometric series, where we have a common factor of 1 plus I to the power of n. So now if you factor out the 1 plus I to the power of n, then we'll be left out with what? With 1 plus I to the power of negative 1 plus 1 plus I to the power of negative 2, then carry on until the last one. So 1 divided by 1 plus I to the power of n, it is the same as 1 plus I to the power of minus n. So as you can see, this looks familiar. So let me highlight it. This series looks familiar. So in the previous, in our previous video, we calculated this series to be what? To be 1 minus 1 plus I to the power of minus n, all divided by what? All divided by I. So now, in order to calculate this, so in order to solve for this, or to simplify this expression, we are going to say, okay, the future value, we are going to say, therefore, the future value equals to x into, don't forget this, 1 plus I to the power of n, 1 plus I to the power of n into what? What is our series here? Our series, sum of our geometric series, it is 1 minus 1 plus I to the power of minus n, all divided by I. Okay. So now let's simplify. It will be x into, so now let's multiply this with our numerator. So now it will be 1 plus I to the power of n multiplied by 1, which is going to be 1 plus I to the power of n. Then multiplying this by 1 plus I to the power of negative n, it will give us, so we have the same base, then we add the exponent to be n minus n, which is 0. So 1 plus I to the power of 0, it will be what? It will be 1. So this will be minus 1, all divided by what? All divided by I. Then after you simplify it, so it basically means the future value. In order to calculate the future value, we have to say, we have to multiply our regular payments by what? By 1 plus I to the power of n minus 1, all divided by what? All divided by I. So note that our I is what? The effective rate. So yeah, that is the formula to calculate the future value. So using this formula, you can easily calculate the future value of an annuity. We usually call these series of payments annuities. Now, for example, if you are saving for retirement or planning an investment, this formula helps you to determine how much your regular contributions will grow over time. Now, I hope this explanation helps you understand the logic behind the formula to calculate the future value.